Welcome to GS Digital Intervention Program for Senior High Schools, Lesson 7 on Investigating Properties of Triangles under Plane Geometry 1. Your facilitator is Professor Christopher Okoti. Dear students, we begin the lesson with a starter on moving matchsticks problems. Make 2 triangles with 5 matchsticks. So I will demonstrate it for you to see. This is 5 matchsticks. You can have it this way, and then have it in that particular way. It will look like a quadrilateral. But the moment you put in the 5th one, you are able to get 2 triangles formed from these 5 sticks. You can use the gum, yes, a gum, chewing gum, and then use the gun as at the vertices to be able to construct the 2 triangles out of the 5 matchsticks. And this you can easily demonstrate in your home, so that you see that mathematics can even be done in their home by playing with even matchsticks and the gun that you have been throwing away. Then the next starter, also still on moving matchsticks. So here, make 4 triangles with 6 matchsticks. Now, in this case, we can demonstrate it also with this. So we have a 6 matchsticks here, and we are making 4 triangles. So here we put the matchsticks at the apex of the triangle formed down, and then they move to the apex. So in this case, it's forming something like a tetrahedron or a triangular pyramid, and then we get in this form. So after demonstrating this, you can use the gum also to do it. In this case, we can remove this and then set it here. So the same thing we used previously, we now set it here and then get it in this form, and then let the 3rd one move on to this point. We can reduce the size here if we wish, and then we clip it. So here we can see this demonstrated that this is 1 triangle, another triangle, another triangle, and the triangle at the base. So we'll be able to form 4 triangles with 6 matchsticks, which is all part of the play in the house. So we can do this activity to see that mathematics is not all that something we should be afraid of, but we can even be playing in the house, give instructions to our siblings, and then we can be demonstrating this. Maybe you can also come out with different number of matchsticks to form a quite good number of triangles, and that will let us. So we can get our drawing as we have found here with the broomsticks. So just broomsticks and a gum, we can demonstrate this quite well, and then the students will enjoy it. So we start the lesson with something like a play, an activity, which students will know that we are not in guests only to come and say people cue this, do that, but just playing activity that will bring the lesson to a good end. So we move on. Now we look at the learning outcome, where we'll be able to investigate the properties of triangles. The keywords will be scaling, equilateral, isosceles, right angle triangle, line of symmetry or axis of symmetry, and rotational symmetry. And then angles, where we talk about interior and exterior angles of a triangle. Our resources are cutouts of types of triangle. We have a equilateral triangle, isosceles triangle, scaling triangle, and then right angle triangle. Now we may also include the geoboard to be part of our resource. So this is the geoboard, which we have demonstrated all these triangles on the geoboard, and we shall continue to demonstrate other activities on it as time goes on. Thank you. We now want to classify shapes. Classify the following shapes into types of triangles. So when we take our geoboard, we'll be able to see that this is giving us the right angle triangle where all the three sides are equal. And then this will be the isosceles triangle where two sides are equal. And then we'll get the scaling triangle here where none of the sides are equal. And then we have the right angle triangle here where one of the angle is 90 degrees. So this classification, we shall go on to look at the various properties of these triangles. So we start with the equilateral triangle, and then we have the scalene, which you can name them. We have the isosceles, and then we have the right angle triangle. From here, we now investigate the sides, angles, and lines of symmetry of these triangles. So let us start from equilateral triangle. Now, we have the equilateral triangle here, and we can see that it has three sides. But what do we observe? These three sides are equal in size. And then you have three angles which are equal. So these three angles are equal. Now let's investigate the line of symmetry. The line of symmetry will fold this equilateral to see whether the area on both sides are the same or equal in area. So we fold it this way, and we see, so this is one line of symmetry. They are equal. And then we do it from the other apex, also the same. We have that. And then the next one also, we do that, and we get this. So it implies that we have demonstrated to the children how to find lines of symmetry in equilateral triangle, and there are three. Please don't quote, let them actually do the activity to come out with the realization of these lines of symmetry of equilateral triangle. We now move on to look at rotational symmetry. This part seems a little difficult for the students, but dear students and teachers, watch how I demonstrate this. You have this cutout and draw it on the paper and see how when you rotate it, it will fit into. If it fits into it directly, then you can say that it is having a rotational symmetry of 1, 2, or 3. So let's look at it from here on the table. So I'll fix it in, and now I'll change the position of the vectors, and then it fits in. So I've gotten one, rotation, symmetry. I'll take another one, I've gotten the second one, and then take the last one, I've gotten the third one. So in this respect, we can say that the equilateral triangle has three rotational symmetries. Students, I hope you have seen how easily I demonstrated it. So if you have hold this one point and rotate it. So if I hold this place, move to this place, I'm getting the same shape. Move to the same place, in a different place, I'm getting the same shape in it. And then move to the, so I've moved this same point 3 times. And that gives me 3 rotational symmetry. I hope you are okay with it. We now go on to investigate that one of a isosceles triangle. Yeah, as you are aware, this is the isosceles triangle. And from our observation, 2 sides, this side and that side, are equal. Now, the 2 sides forming an angle with the third line are also equal. So this angle here is equal to that angle. So we can say that the isosceles triangle have 2 equal sides and 2 equal angles. Now, let's observe how to find the line of symmetry for the isosceles triangle. In the same way, we try and fold and see whether we'll be able to get equal areas after folding. So we fold it from the apex here. Now, we are getting this to be equal to that. Because these two sides were already equal from the beginning, as we said. So these two sides are equal, so we have gotten these areas to be equal. But then let's try whether it will be equal when we fold from other vertices. Now we are now folding from other vertices. Dear student, watch for yourself. Look at this area and look at this area. Are they equal? No. You can see that they are not equal. So we can call it a line of symmetry. We can do for the other one too, and fold this way. This is that, and that also is that, whereby the areas are not the same. So we can conclude that it is only one part that we can get the line of symmetry from the vertex of where the two equal lines meet. That line over there will give us the line of symmetry. So we conclude that we have one line of symmetry for isosceles triangle. Now let's just investigate the rotational symmetry. Just like how we did for the other one, we draw the isosceles triangle on the paper down, and the cutout is placed into it. Now here we have this into it, but then we move from here and see that this road changing to this place, we are going to get something like this, which will not fit into it at all. So we move it to this place, it will also not fit into it. So in this case, we cannot talk about any rotational symmetry. No rotational symmetry for the isosceles triangle. And then that is demonstrated for you to see. So it's practically stated, not quoting, but you are getting it. We now move on to the next one, which is scaling. Scaling here, when we observe this cutout here, we can observe that the three sides, none is equal to each other. And then the angles formed also, none is equal to each other. So you have this as one of their basic properties. They are not equal. Now let's look at the line of symmetry. With the same procedure, we fold. And when we fold this from any of the vertices, this the area, and that is that you can make your deduction or conclude that this area is not equal to that area. As well, we can fold from another vertex, and we see it like this. Even this is west. This is the area here, and look at the area at the back there, so big that they are not equal. We fold from another point to, you are getting it this way. Look at the SS. So they cannot be equal. So in this case, we can conclude that the scaling has no line of symmetry. Again, we demonstrate how to find the rotational symmetry of the scaling. So we continue to demonstrate how to find the rotational symmetry for scaling. So we put the cutout on the drawing here, and then we hold one part to the various vertices to see whether it will hold or to fit into it. Now if we move this, it is clear that it may not fit into it. We move the same point to the other vectors on the diagram, and it will not fit into it. So in this case, we can say that the scaling has no rotational symmetry. So that is property in that form. We now move on to right angle triangle. Now the basic property or characteristic of a right angle triangle is that one angle is 90 degrees, which we can see over here. So we use this sign in the form of a chair to demonstrate right angle triangle. Now, we may have a right angle triangle that none of the three sides are equal. So that would be scalene right angle triangle. In that case, the properties will just be like the scalene triangle. But we may have a right angle triangle that have two sides equal, and that will be isosceles right angle triangle. So two of the sides will be equal. So when we take this drawing here, we see that from this place going in that way, this part is equal to that part. So we are getting two sides equal, and therefore if the two sides are equal, the angle here and the angle there will be equal. So that makes isosceles right angle triangle have two equal sides and two equal angles, just like isosceles triangle. Similarly, looking at its symmetry, if it is the scalene right angle triangle, there will be no line of symmetry. But if it is the isosceles right angle triangle, there will be one line of symmetry if the two sides are equal. So we can easily get it in this form if we fold it. Yeah, if we fold it, look at the lines. So look at this line here, look at that line here, and then you see that we are getting the same area. The area from this and this line is giving us the same area as this line and that. So that will give us one line of symmetry where we are folding on the vertex where we have the 90 degrees. So we can get it in that way. Similarly, we can get one rotational symmetry for isosceles right angle triangle, and then it will move in that particular form, and we can get it in that form. So we have demonstrated these properties of the triangles, and then we can now put it in the tabular form so that our students will be able to get it. So dear teachers, after getting the pictures and these demonstrations, you can put this also in the classroom for the students to use it as a reminder, not to cue, but they remind it, and anytime you see anything all the time, you'll be able to have it in memory and be using it, so they can look at the characteristics of these triangles, which we have demonstrated on this table. And I believe that your student will be able to use them in working many examples. Now let's look at some applications of what we have done. Shapes of triangles. We will be able to see it in our clothes, shirts, wallpaper. Industries are using it, Texas industries, and all are using these shapes. Even I happened to get to a hotel where I saw that all the paints were done in triangles, which was very beautiful. So check in your house. Student, you can see that maybe some of your dresses, we have triangles design in it. We can use it in our homes as well. Now, even in our lawns, that garden, we can draw or we can shape the triangles in the garden or on our walls just to create some beauty in your house, to make your house a mathematical home. And that will let it go very well. So we have talked about line of symmetry too. We see it being used by tailors and seamstresses. That in designing dresses, this line of symmetry makes the shirt very beautiful. Even as we human beings, we can look at our line of symmetry from our forehead through our nose, parting our nose into two, parting our mouth into two, and then coming down, and then parting using our buttons as I have that down. So one leg here, one leg there. So when you look at the types of things you have on the left side of your body, they are also at the other side. In the physical, not when you get inside, because the inside cannot be symmetrical. But on the physical or the outside look of the human being, you can easily identify the line of symmetry over there. We are now on assignment 1, and I would like you to snap it or write it. Take 1 minute to do that so that you can be able to do it in your convenient time. So we have a triangle here. You have angles ABC, which we can see them outside the triangle. So we call them exterior angles of a triangle. And then we have angles DEF inside the triangle, which we call interior angles of a triangle. I want you to do these measurements and come out with these observations. Measure angles A, B, and C and add them. Measure angle D and E and compare their sum to C. And then measure angle D and F and compare their sum to B. And then measure angles E and F and compare their sum to A. What are your observations? This will help you to solve questions in the next assignments. We are now on assignment 2. Snap or write these questions for just 1 minute so that you can do it at your convenient time. Question 1, find angle X, where angle X is exterior angle of the triangle. We have angles 37 degrees and 79 degrees to be interior angles. So use the concept you acquired from assignment 1 to answer this question, find X. And then question 2, that to find A, where A is an interior angle, and you have a second interior angle which is 80 degrees, but you have 130 degrees as an exterior angle, which you have to use it to answer and find the value for A. Yes, students, we move on to assignment 3. Here is more of discovery, observing that idea. And then we are asking you to find or follow your drawing. You have heard of the following types of triangles: acute angle triangle, and then obtuse angle triangle. What do you know about them? Draw and write 3 things about each of these triangles. So you have to understand the language acute. So as you know already, acute means angles from 0 to 90. Then within that range we say acute. But beyond 90, to 180, we say obtuse. So in this case, try and draw triangles of this caliber, observe them, study them very well. We may use them in our next lesson. Now, on reflection, meaning we've gotten to the end of our lesson. What have we learned today? We, you and your teachers, we have been exploring the features of triangles, their properties, and then how to use them subsequently for other activities. Hope to meet you in the next lesson where we shall investigate Pythagoras' theorem by using the right angle triangle which you studied earlier on. Thank you for listening.